Okay, so we have our goal, and our goal for this first example is here. So the goal is to set up the appropriate right triangle that's going to allow us to convert this integral, which is in terms of x and dx, into an integral in terms of theta and d theta. So remember, this is the first step in doing the trig substitution. You convert stuff in terms of x dx into an integral involving stuff in terms of theta and d theta. Okay, so as I'm looking at this integral, what strikes me is this part in the denominator. So if I have the square root of 9 minus x squared, what that says to me is that if I make a leg the length 9 minus x squared, and then if this other leg has a length of x, now, according to Pythagorean's theorem, I'll have x squared plus the square root of 9 minus x squared, quantity squared, is equal to my hypotenuse squared, right? So here's my hypotenuse. So let's see here. So then if we simplify, we'll have x squared plus 9 minus x squared equals hypotenuse squared. Okay, the x squared and the negative x squared will cancel each other out. I'll have 9 equals hypotenuse squared. So it'd be good for me to set my hypotenuse equal to 3. The length of this is actually 3. Now I have my triangle set up. This is the triangle that I'm going to use. And once I put my angle in, so I can put my theta here. If I put in my theta here, I'm ready to go. I need to convert each part of my integral. I need to convert my integrand and the dx into terms involving theta. So now how am I going to do that? The terms that I have so far are, dx, and I have 1 over, so let me actually write this because there were some people that made this error. There are several students that made this error on the quiz. So let me just rewrite this. Notice that this is the same integral as the integral we've been given.
It's 17 hours.
So I can rewrite this as 1 over x squared times 1 over the square root of 9 minus x squared dx. And now I can simply look at it like I have 3 little parts to kind of translate. 1 over x squared, and I have 1 over the square root of 9 minus x squared quantity. And then lastly, I have a dx. Now, 1 over, and so this is my column, stuff in terms of x and dx. And I want to convert it into stuff in terms of theta and d theta. And I'm going to use the triangle to help me kind of figure this out. So we can actually go ahead and make a nice little chart here. That'll be possibly helpful. Okay, so my stuff in terms of x. Okay, so the first thing I have here is 1 over x squared. Now I need to figure out what is 1 over x squared in terms of theta. I look at my triangle, and from my triangle I use my trig to say, well, sine of theta is equal to opposite over hypotenuse, right? X over 3. This gives me the relationship between x and theta. So if sine of theta is x over 3, that means x is equal to 3 sine theta. How did I get that? I just multiplied both sides by 3, right? And if x is equal to 3 sine theta, that tells me that 1 over x is 1 over 3 sine theta. And this is the same thing as 1/3 cosecant theta, right? Because cosecant theta is the reciprocal of sine of theta. Now, I'm almost there. Remember, what do I need? I need 1 over x squared. So far, I've got 1 over x. So I just am going to square this. 1 over x squared. That'll give me my 1 over x squared, which is 1/9 cosecant squared theta. So that's what I'm going to put here. 1 over x squared is the same as 1/9 cosecant squared theta. Now what about 1 over the square root of 9 minus x squared? Again, I go back to my triangle and I say, what's the connection between theta and the square root of 9 minus x squared? Well, looking at this, let's look at cosine of theta. So now cosine of theta is going to equal adjacent over hypotenuse. So for us, that's going to be the square root of 9 minus x squared over 3. So that means that the reciprocal of cosine of theta, which is going to be secant of theta, is going to equal 3 over the square root of 9 minus x squared. That means 1 over the square root of 9 minus x squared is 1/3 secant theta. Right, so I just kind of divided both sides by 3. Let's see, I don't know if it's too far down here. But yeah, so here I kind of just divided both sides or multiplied both sides by 1/3. You can look at it like that. The 3 and the 1/3 cancel each other out. So I get 1 over 9 is equal to 1/3 secant theta. So I can put that in my little chart here. 1 over the square root of 9 minus x squared is 1/3 secant theta. And the last thing I need to compute is dx. This is where students typically lose it. And they just say, oh, dx is d theta. Wrong, wrong, wrong. In fact, let me use my... No. We can't do that. How do we find d theta? Again, we have to go back to our triangle. At this point, I would use the relationship right here. So if I know that sine of theta is equal to x over 3, then I can use that to compute dx over 3, right, is equal to cosine theta d theta. So how do I get dx? Well, dx is going to be 3 times cosine theta d theta. Okay, so let's erase this, which is incorrect, and we'll get 3 cosine theta d theta. And it's important to do it this way as well, because if you compute your dx properly, then terms will cancel out. If you just change dx into d theta, you just say, oh, dx must be d theta, it's going to be impossible to complete the next step, because terms in your integrand aren't going to cancel out like they need to. Okay, so I can put all of this together. And putting it all together, I can rewrite my integral. So the integral of dx over x squared times the square root of 9 minus x squared, which is the same thing as we said, the integral of 1 over x squared times 1 over the square root of 9 minus x squared dx is equal to the integral of, now instead of 1 over x squared, I have 1/9 cosecant squared theta. And instead of 1 over the square root of 9 minus x squared, I'll have 1/3, so this is being multiplied, 1/3 secant theta. And then instead of dx, I'll have 3 cosine theta d theta. All right, so certain terms will cancel out, like the 3 and the 1/3. The 1/9, I can pull it out front. Okay, so I have 1/9 integral, the integral of cosecant squared theta, secant theta, cosine theta, d theta. Now, guess who cancels out? Secant theta and cosine theta cancel out because they're reciprocals of each other. So I'm just left with 1/9 the integral of cosecant squared theta d theta. So what I would like to call your attention to is the fact that I'm done with step 1, because I have an integral in terms of theta and d theta, whereas I started out with an integral in terms of x and dx, okay? So if we were to kind of write like a synopsis of what we did in this step, here's what we would write. We would simply write that the integral of dx over x squared times the square root of 9 minus x squared is equal to 1/9 the integral of cosecant squared theta d theta. And now I need to tell you the relationship between x and theta. So I'll do that down here. Now I'll have my triangle. I can do better than that. Okay. And then I'll say down here, what did I use? I used x, 3, theta. And then down here is the square root of 9 minus x squared. Okay. So this is the complete step 1. Okay. The reason I want to point this out also is because on an exam, some students, might have learned to just memorize, if you see this, then this is what you write. And that is not what I'm expecting. So on an exam, I'm expecting, and also on the homework, so this is exams as well as homeworks, exams and homework and quizzes. Let's go on and put that in there if there's an issue. What I'm expecting to see is this triangle. So this triangle, this will let me know that you understand, right? This triangle right here is going to let me know, just like how you tell me your U substitution, this triangle lets me know that you understand how we're converting our integral in terms of x and dx into an integral in terms of theta and d theta. So this, right, and this is what we need. That's what we're looking for. Okay, let's go ahead and actually look at a second example here. And for the second example, the instructions are the same. And what we have is the integral of dx over 1 plus 4x squared. So I want to show you a way to do this problem. You might be saying to yourself, hey, where's the square root, right? What happened to the square root? Well, here's where we can kind of throw in a square root if we kind of need a square root. We've got 1 over 1 plus 4x squared dx. This is what we're integrating. And you can think of that as the square root of 1 plus 4x squared squared. Do you see? So even though there isn't a square root showing explicitly in the problem that we've been given, we can just rewrite it. You know that there is a square root involved because you can just think of the square root squared. Okay? So, how are we going to apply our triangle? The key is in the square root of, the key is in this 1 plus 4x squared. Because when I see that, I see 1 squared plus 2x squared, right? And I think a squared plus b squared, right? And I think c squared, right? So the idea is if you have a triangle, here's a, here's b, here's c, a squared plus b squared equals c squared. So I know how to set up my triangle. I'm going to have one leg be 1, and the length of another leg is going to be 2x, and the length of the hypotenuse is going to be the square root of 1 plus quantity 2x squared. Okay? And we can write what is the square root of 1 plus quantity 2x squared. We already know that's going to be the square root of 1 plus 4x squared. That's in fact how we chose 1 and 2x. Okay, so we may as well just write 1 plus 4x squared, square root of that. Now, the issue is, where do I put my theta, right? Now, before, so in the last triangle, we put theta down at the bottom and to the right. And that's typically where I'll put theta. But I wanted to do this example and show you that it kind of doesn't matter. You can put theta up at the top. It still works. Why? Because the right triangle still works. So now, we're ready to convert stuff in terms of x. What stuff do we have in terms of x? We've got 1 over 4x squared plus 1, and we have a dx. And we need to convert this into stuff in terms of theta. Okay, so this is x and dx, and we're going to convert each of these symbols into terms involving theta and d theta. Now, how are we going to do this? We need to figure out what's the relationship between theta and x. So on the one hand, I'm looking at theta, and based on this triangle, what is tangent of theta? Tangent of theta is opposite over adjacent, which is going to be 1 over 2x. So that's one relationship I found. What's sine of theta? The reason why I'm moving on to other relationships is because 1 over 2x, this is true, right? 1 over 2x equals tangent of theta. This is very true, but it doesn't appear to be helpful because I'm kind of trying to figure out 1 over 4x squared plus 1, and that does not look really like 1 over 2x. So I need a relationship that's going to involve this square root of 1 plus 4x squared. So what is sine of theta? Sine of theta is opposite over hypotenuse, which is going to be 1 over the square root of 1 plus 4x squared. Bam, I'm done. Because now if I square both sides, I'll get what I need. Right, so sine squared theta is going to be 1 over square root of 1 plus 4x squared, all of this squared, which is 1 over
It's
1
1750.
4x squared. So 1 over 1 plus 4x squared is sine squared theta. Okay, now what about the dx? For the dx, I actually am going to go back to this relationship here. Because if tangent of theta is 1 over 2x, erase this, then I can just solve that for x and then just take the differentials. Okay? So since tangent of theta is 1 over 2x, that means 2x is cotangent of theta, right? Which means x is cotangent of theta divided by 2. Which means dx, oh boy, now I've got to try to remember my derivatives, right? So what's the derivative of cotangent of x? The derivative of cotangent of x is negative cosecant squared x. So dx is equal to negative cosecant squared theta over 2 d theta. That's all I'll put here. Negative cosecant squared theta over 2 d theta. Okay, and so now for my last step, I want to, or kind of just, got to put it all together. So this integral of dx over 1 plus 4x squared is equal to the integral of sine squared theta times, I've got negative cosecant squared theta over 2 d theta. We can bring that negative 1/2 to the front. Integral sine squared theta cosecant squared theta d theta. And then sine squared and cosecant squared cancel out, right, because they're reciprocals of each other. So we're just going to get negative 1/2 the integral d theta. All right. So again, if we were to summarize this, the summary would be that the integral dx over 1 plus 4x squared is equal to negative 1/2 the integral d theta. And then we need to give instructions on how to form the triangle. And the triangle that we used in order to get this integral is, let's see, down here's a 1, up here's a 2x, and this is 1 plus 4x squared square root, and then here's our theta here. So if you were to use a different triangle, so if you use a triangle and you put your theta in the opposite angle, right? So imagine if you put theta down here, then that's going to impact the relationships that you have here. So instead of tan and cotan, and I think we use sine as well, you're going to be looking at cotangent and cosecant, right? So, you know, there are definitely two different ways to use trig substitution because you've got two different locations to place your theta in your triangle, right? Because you can place it in this angle or you can place your theta down here. So that's going to give you two different ways to interpret this integral. Now the last thing I want to mention is that we could do this problem right here, we could actually do with a u substitution, let u equal 2x. And then this turns into a constant times the integral of 1 plus, the integral of dx over, or du over 1 plus u squared. So it's a constant times arctangent. Okay, arctangent of 2x. All right. So this is how to set up. This is how to do step 1. And with more practice, it's faster to do it.